All right, welcome back everybody to Elite Star Training and our land navigation module of our basic search operations course. We are now going to switch over to the next video where we're going to start talking about the US National Grid and UTM coordinate systems. These are the coordinate systems that we use for land navigation in wilderness search and rescue. USNG, again, it stands for US National Grid, and UTM stands for Universal Transverse Mercator. If you're ever in a trivia contest and that question comes up, you can thank me later on for knowing the answer to that. But these are the preferred coordinate systems for land-based navigation in search and rescue. They're very similarly structured. They're very similar. They both are based on the concept of dividing the map into zones. The difference being the USNG focuses more on North America, while UTM divides the entire world into zones. The US National Grid is an alphanumeric reference system that overlays on top of the UTM coordinate system, which again, it's divided into zones across the world. And what you see here are the zones for the lower 48 states. Okay, in both US National Grid and UTM, these zones are going to be the same. The zones, the outline, it's going to be the same. What they do is they take these, they grid out the world into zones, and what both of them will do, but US National Grid does it a little bit differently. US National Grid is going to break it down into square IDs. These are 100,000 meter squares, what you see here. But the coordinates for both UTM and US National Grid are derived from measurements west to east and south to north. And we'll talk about that later on. Whenever you read this, you'll hear me say this ad nauseum as we're going through here. You read to the right, and then you read up. Okay, that's how we read it. We read it from west to east, and we read it from south to north. Okay, that's how we're going to read that. And here is an example of the same spot, the same position. This is the boat ramp that we looked at in the last video. The same position represented by these two different coordinate systems. The difference between the two is how the first two UTM measurement digits, the 100,000 meter digits, are represented. UTM is going to represent those with digits, while US National Grid is going to represent these with square IDs. You can see that here, right? So these two numbers right here, the 16S, those are the same. Those numbers are the same. Whenever we get into these, the first set of numbers here, up here we have a 05 in the UTM. Underneath of that, it's EG in US National Grid. The remaining five numbers there are the exact same. Okay, the 22117, that's the exact same. Okay, the only thing that's different are the first two characters of that coordinate. Okay, looking at the second part of the coordinate, let me erase the stuff there. Looking at the second part of the coordinate, the UTM starts the northerning, that's the part where we read up. Okay, the northerning is the part where we read up. It starts it off with the 4 1-digit, but you can see right here, US National Grid, it's not there. It's omitted. Okay, it's those digits are omitted, but you can see the last 5 digits of the coordinate are still the same. The 95177, that's still the same on both of those. Okay. So there's a lot of similarities between these two coordinate systems, and it's really just how they're represented. They're basically the same. It's just how it's represented a little bit differently. It's a lot easier whenever we start talking coordinates in the field to verbally say the US National Grid coordinates. However, historically, I've always taught the UTM coordinate system. That was a standard for a long time, and it was very much the standard that I've been teaching over the year. But over the past couple of years, I've started to switch more towards teaching the US National Grid coordinate system because this aligns with whenever you look at the NASAR literature and you look at the fundamentals of search and rescue, that's what they teach. They teach U.S. National Grid. So I've started to switch from really going UTM heavy to U.S. National Grid heavy, but they're very close, very similar. Once you get the hang of it, you'll find that it's seamless. Okay. So this slide again is going to show the differences between the two coordinate systems, but as you can see in the margins have the same big numbers, okay? The same big numbers. So like here, for example, we have the number 18, okay? We have the number 18 here in the bottom left. We see in our UTM, okay, and this is U.S. National Grid. This is UTM, okay? You see the 18 down here at the bottom left, and over here on the UTM, you see the big number. The big number, again, is 18, okay? We try to circle that a little bit better here. You see the big number there is 18. So from a small scale land navigation perspective, these coordinates are going to read identically, meaning the two coordinate systems can be used interchangeably in the field with little issue, okay? And then with the scale utilized on the map, and this is something I alluded to in an earlier video, with the scale utilized on the map, the 1/24,000th scale, the blue grids are going to represent the zones that are being broken down into 1 square kilometer. Let me erase this right here. So these blue squares here, this right here is 1 square kilometer. Okay, that's what's being represented there. Each edge around the square is 1 kilometer in linear length, which can be navigable on the ground, but we need a little bit of help breaking this down further to get to a specific point. We can get to a 1 square kilometer, but there's a lot of stuff that's going on inside of that kilometer. If we're looking for a lake inside of this, that's going to be pretty easy to find. If they say we need to get to the west side of this lake, that's going to be pretty easy to find. But if we need to get to the campsite or the end of this road in there, we need a little bit more to get us to a specific spot. We need to break it down a little bit further. And that is where the grid reader enters. And you may have used these in the past or heard about these in the past, but what the grid reader is going to do is going to break down those larger 1 square kilometers into 100-meter squares. Okay, so that's what you see inside of here. You have the 100-meter squares inside of these little bitty squares. That's 100 square meters. 100 square meters. Okay, much smaller target. So then we can dial in a lot better. You know, being able to get down to that level, it's going to allow us to navigate to a more specific point, and we can add additional digits on the end if we want to get us, you know, even closer down to 10 meters, which is considered pretty accurate. If we get you within 10 meters of something, that's pretty accurate, because whenever I'm giving someone coordinates from the command post, what I'm trying to do is I'm trying to get them to an easily identifiable location. I'm trying to get them to something that whenever they get there, they know they're going to be there. You know, that's a road intersection or a vantage point or a body of water. It's something, you know, whenever you get down to the 10 square meter level, you know that you're in the right spot. You know what I was trying to get you to, okay? That's what we're trying to do there. And let me go ahead and advance, and then we'll come back to, I'll show you guys some of the equipment that I've got for this. I think we'll do it after these next couple slides here. So whenever we talk about plotting a coordinate, the rule for U.S. National Grid and UTM is both going to be the same. We read to the right, and then we read up, okay? So we have a coordinate down here at the bottom. We're trying to mark a specific spot, and it's at 22,3,946. This is our coordinate, and this is in UTM. This is in USNG, okay? But this is our coordinate. So the first thing we need to do is find the prime number for each digit, okay? The first two numbers on each digit, and we're going to find those in the margin of the map. So We identify the 22. If we go to the right, we start down here, we read to the right, and then we read up. So this is going to be number 1. This is going to be number 2. We read to the right, and we find 22. That means everything inside of this column between these lines is considered the 22 column. Okay, that's what it's going to be considered. All right. Now for the 94. Step 1 was read to the right. Step 2 is going to be read up. We're looking for 94 is what we're looking for. We go up, we find 94. That means everything above this line and everything below 95 is considered 94. This is considered 22, okay? So what we're trying to find is we're trying to find where 22 and 94 intersect, and that's what we have here, okay? So this is our square kilometer. The point that we're trying to get to is somewhere in this 1 square kilometer, and we need to overlay the grid reader to get us dialed in to those last 2 digits. So we'll flip over to the next slide. Again, the same principle is going to apply. The exact same principle is going to apply. We read to the right when we lay down our grid reader. We do that first, and then we read up. That's number 2. And so we've already got 22 and 94 squared away, so we're done with those. We're focusing on the 3, and we're focusing on the 6. So we read to the right, we find 0, 1, 2, 3. We're somewhere in this column. Okay? Then the same thing over here, 0, 1, 2, 3, 4, 5, 6. We're in this row. Okay? So where those 2 intersect, that's our spot. We're trying to get to the top of this hill. Let me go back here. We're trying to get to the top of this hill is what we're trying to get to. And over the radio, as I'm giving you those coordinates, I'm saying, hey, I'm trying to get you to the top of the hill, exit to the end of this road, and I want you to get to the top of the hill so that way we can see down to the tracks and into the river on the other side. And I would give you the coordinates so that way you have an idea of where I'm trying to get you. Now we're plotting it. We have gone through and we have read to the right. We have read up. We have seen where this intersects here. And we know that that's 100 square meters. That's where I want you to get at. Okay? That's going to get us pretty close. We can take that a step further. By adding an additional digit to the end. Okay? The rule is still the same. Read to the right and then read up. The rule is always the same. But by adding this additional digit, we can get you within 10 square meters of an intended target. This may sound very technical because our grid reader only has, it's not broken down that way. The grid reader gets you to 100 meters square, but you have to conceptualize a little bit. You have to think of the grid within inside the grid here. Okay, you'd have to think that inside of between this line here and this line here, there are 10 hash marks. This right here is 5. Being in the middle is 5. So you can kind of think of this is 6 through 9. On the other side here, it's going to be 4 through 0. Okay, you have to kind of conceptualize that as you're going along. And that's where this would be at. So with that logic, a 9 on our easterling, it's going to be pretty close to this line right here. It's going to be pretty close. It's actually going to be a little tighter than that. But that's just where I drew it with my little pin here. So it's going to be pretty tight there. And a 1 is going to be pretty close to the line down here at the bottom. You have to conceptualize that. So it takes a little bit of practice, a little bit of remembering. But the rule is the same. That's a great thing about this coordinate system is the rule is always going to be the same. Read to the right and then read up. You're always going to start at 0 and end at 9, no matter which way you're going. Okay? So what you're doing there is we can dial that in even further, and by adding those digits, we're in this column, and we're in this row, and by adding the 9 In the one, we've dialed that into 10 square meters. We've gone from 100 square meters to 10 square meters, and that's pretty doggone accurate for land navigation. Okay? So where you can pick up let me switch back over to this real quick, and I'll walk you through what I've got. So if you go to maptools.com, maptools.com is a really good website and has a lot of really good land navigation tools. But you can go on there, and this is my compass that I carry, and this is my grid reader that I carry. They produce a very good, high-quality grid reader. I've had this one for years, and I'm not sure if you can see on the camera how beat up and how scarred up and scratched it is. I probably need to get a new one, but this thing like legit costs like $5. It did not cost much at all. But they produce a very good grid reader, and it's got a hole punched in it so you can stick it on a lanyard. But they also have a lot of really good other information on how to use grid readers and how to navigate using a map and compass. I'll put a link in the description of this video to where you can find their grid reader, but I also urge you to check out some of their other resources that they have available on their website. Very good stuff. I've worked with them before. They're very friendly, very responsive. They have a lot of really good stuff out there that you can go out there and play around with. Like I said earlier, with the orienting your map to your location and marking geographical features, what I'll do is I'll put a link to this map in the as part of the recording. I'll put it in the description of the video and a list of points for you to search for on the map using the grid reader. So go out to Map Tools, pick up a grid reader, and then you can come back and do the homework assignment on that. Print out the map and mark those points on the map. Okay. It takes a lot of practice. This is one of those areas that takes a lot of practice. You're gonna have some frustrating moments of trying to get it, but once you get it, I promise it clicks. Because the rules never change. And I mentioned that before. The rules are never going to change. So once you kind of get it, it's a lot easier to really hang on to it. This is important because I've had to do this on searches before. I've had to do it where this was how we navigated. We didn't have phones available to us. So this is how we had to do it. But it's a good skill to learn. A lot of this has been replaced by electronic mapping, but this is a very good skill to have in your toolbox there. And I believe that is going to bring us to the end of our video. Let me go back to this. This is going to bring us to the end of our video today. Appreciate you guys watching. We have one more quick topic right after this, and then I think we have two more topics left on this one, and then we can wrap this up. So thanks for watching.